In the lesson 5.4 example, can you tell bottled water from tap water? We're going to calculate binomial probabilities with technology, cumulative binomial probabilities. Mr. Bullard's class did an activity to see if students could tell bottled water from tap water. There are 21 students in the class and each student was given 3 cups, 2 that contain tap water and 1 that contain bottled water in random order. The student was asked to identify which of the cups they thought was the bottled water. And if we assume that the students in Mr. Bullard's class can't tell tap water from bottled water, they have a 1/3 chance of getting the correct, making the correct identification just by chance. We're going to let X be the number of students who correctly identify the cup with the bottled water in it. And if 21 students are in the class and 13 made the correct identification like we have here, are we convinced that Mr. Bullard's students can tell bottled water from tap water? We want to know how likely it is that X, the number of students correctly identifying the cup with the bottled water, would be at least 13. And we're going to calculate this probability using technology that comes along with your textbook. In this scenario, students have a 1 in 3 chance to select the cup with the bottled water just by guessing. So they have a 1/3 chance of getting it correct. We would expect about 1 out of 3 students to get the correct cup just by chance. X is binomial, therefore, with n equals 21 and p equals 1/3. And so we want to know what the probability that X is at least 13 is. We can do this 2 ways, and I'll show you both. One is doing 1 minus the probability that X is less than or equal to 12. You can find that probability on any calculator, but what I'm going to show you is how it might be done using the applet that comes along with your textbook. You can find this at highschool.bfwpub.com/SPA3e. You'll notice that I entered binomial distribution up here, and we are using n equals 21 and p equals 1/3. We can find probabilities from that distribution, for instance, at most 12 successes like I have down here. That will give us this number. We can see that when we calculate that probability, it's told to us to be 0.9932. So subtracting from 1 gives us 0.0068. Not very high. Conversely, you could have just calculated that directly. Now this is not something that most calculators will let you do, but you can do it here in the applet. You can calculate the probability of between 13 and 21 successes. And just like before, when we did the subtraction, it gives us the same number, 0.0068. So let's interpret what we saw here. The students have a less than 1% chance of getting so many correct, or even more than 13 correct, if they were just guessing. Because that's unlikely to have happened by chance alone, there's convincing evidence that at least some of the students in Mr. Bullard's class can distinguish bottled water from tap water. Probably some of those 13 just guessed correctly, but at least some of them can distinguish bottled water from tap. If you'd like to try a problem like this in your textbook, you can try exercise 9 in this section.